Hello, I'm Rebecca the Maths Lady, and in this video I'm going to be explaining how you can help your child achieve a secure first understanding of division that's going to set them up really well for the future. In this video I'm going to explain how division is sharing things fairly, and it is also counting groups, and how both of those ideas make sense at the same time. I'll explain multiplication and division families of calculations, and I'll also explore why you can't just swap the order of the numbers in a division as you can with addition and multiplication. If you already understand all that and you don't need this video, here's your link to skip to the next one. Before watching this video, I recommend you watch the video on the foundations of multiplication, because it introduces the idea of multiplications being rectangles of squares, which is an idea we'll be building on in this video. So if you think you need that video, here's a link to it now. Okay, let's get started. Here's a division that I've often used in training with teachers and teaching assistants. 15 divided by 3. And I give them 15 objects, typically just cubes, on the desk in front of them. I'm using magnets on this board so I can show you. And I ask them to shut their eyes and divide their 15 objects by 3 to show me the answer. And in a room full of people that I'm training, two things happen. Some people do this. They divide their 15 objects into 3 equal groups, and they tell me that the answer is 5 because there are 5 objects in each group when we split the 15 fairly into 3 equal groups. And they're entirely correct. But other people in the room split the objects into groups of 3 and tell me that their answer is 5 because there are 5 groups of 3. And they are also entirely correct. There are these two big ideas of division. It is sharing the amount that you're dividing fairly into this number of groups and finding the size of a group. And it is also counting how many groups this size there are in this number. And here we really get to the point of studying maths education. When you're just doing maths, it doesn't matter which of these you do, and you don't have to have an awareness of the other one. But when you're teaching maths to someone, you need to understand the different ways that people understand things, because if your method of understanding it clashes with the person that you're trying to teach, particularly if they're a child, then you're going to confuse them. So what we need to look at now is why both of these ideas make sense together. And when I'm running training, what I typically do is get out a pack of cards, count off 15, and I deal them out like this. I deal them out between 3 people. But as I do so, I arrange them in columns. Like this. And then I ask them, which have I done? Have I found that the answer is 5 because I've shared these fairly into 3 groups, sharing the cards between the 3 people? Or have I found that the answer is 5 because I've counted groups of 3? And there are 5 groups of 3. And as is often the case in maths, the best mathematicians are the ones who are confused and are thinking slowly, because this particular way of organising objects in a rectangle shows both models at the same time. It shows the 15 counters split into 3 equal groups and that there are 5 counters in each group, and it also shows them in 5 groups of 3. Essentially, it's about looking at it sideways to see the other picture that you didn't see before, that's not your preferred picture. Just like when we were exploring how multiplication can be done in either order, if you look at it sideways, you see it the other way around. And this is the point at which many children get really confused with maths. And if you're the adult working with them and you're very comfortable and confident that division is both sharing fairly and counting groups, and whenever you swap between the two, you just say, well, division is sharing fairly and counting groups. We can use either. I'm using this one. You can use which one you prefer. And you connect with their thinking, whatever it is, you're going to take them on a really successful learning journey instead of confusing them. Let's explore this idea a little more with this calculation. 84 divided by 4. Now, there are two ways we can do this. One is to count groups of 4. Now that's pretty tricky because it involves breaking up so many tens. But if a child's done a lot of work on tables and has learnt simple divisions off the back of doing tables, they're used to counting groups. That happens naturally. So there's a significant shift that needs to take place if you're going to guide them in the direction of sharing fairly, which is so much easier for this calculation. It's really easy to say, well, 84 divided by 4, let's share this fairly into groups for 4 people. Here we go. The answer is clearly 21. But if the child you're working with isn't used to seeing division as sharing fairly, if they're used to counting groups, you need to take this really slowly. And if they want to exchange all of these tens into ones and count groups of 4, you may need to let them, and that might be really powerful learning. But then you want to show them this way and confidently say, look, you can do division as counting groups, but you can also do it as sharing fairly. And sharing fairly is so much easier in this case. It's what you want to do. And you've got every chance that they will take that journey with you. If you just cut across them and say we're sharing fairly and they're not clear what you're doing, you can lose them, and a lot of children lose their confidence in maths at this stage. Let's have a look at these two questions. 2004 divided by 2 and 60 divided by 20. Which strategy do you use to solve these? Do you share fairly or do you count groups? You could do either because both work. For 2004 divided by 2, you could count up how many 2's are there in this number. And there's various ways of taking shortcuts to do that that will get you there. But it's much easier to try and imagine this number in your head and split it into 2 equal parts. It's clearly 1002 when you split it in half. So sharing fairly is the most efficient strategy to use here, and it's what most adults would do. What about 60 divided by 20? Well, you could share fairly. If you've got 20 people and 60 sweets to share fairly between them, you can imagine giving each person 1 sweet and then each person another sweet until they're all gone. And each person ends up with 3 sweets. And some people will do that. But it's much quicker to say how many 20s in 60, because that's clearly 3. And a lot of adults actually switch between sharing fairly and counting group strategies without being aware they're doing it. They do it subconsciously. And that's really confusing for children. So again, it's essential you know that division is sharing fairly and counting groups, and that whenever you're talking about a division problem with children, you repeat that. You're confident why it's both, because you can organise the objects as an array and you can explain that to them if necessary, and you slow down to listen to what they want to do. And if you're trying to get them to focus on one particular strategy, you listen to them first and take them on a journey from their thinking to where you want them to go. If we come back to our original question, which was 15 divided by 3, we can also think of it as being a question about finding the missing number in a multiplication. 3 times what is 15? Now, in our videos on multiplication, I showed you the benefits of organising multiplications as rectangles of squares. If we do the same here, what we're doing is saying we have a rectangle of squares. One side is 3 squares long because we know one number. And we know there are 15 squares in the rectangle. So the question is, how long is this rectangle? And you can find that answer either by splitting the 15 into 3 equal groups or by counting groups of 3 until we've got all 15. Either way, we end up with a rectangle. We have 15 squares in the rectangle. This side is length 3, and what we want is the length of this side, which turns out to be 5, whichever way we do it. And that leads us to a calculation family that all fits together. 3 times 5 is 15. 5 times 3 is 15. Just looking at the same rectangle the other way round. And 2 divisions. 15 divided by 3 is 5. If we didn't know that number and we just knew the total was 15 and one side was 3. But then there's also the question where we know that one side is 5 squares long and we're trying to puzzle out the other one. If we're doing 15 divided by 5, we can either say how many groups of 5, and that tells us the height of the rectangle, or we can share the 15 equally into 5 groups. If you imagine a person here, 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 how many squares does each person get to fill up the 15? However we do it, it turns out to be 3. And our fourth calculation in this calculation family is 15 divided by 5 is 3. They're all shown by the same diagram. In multiplication, we know the side lengths and we're trying to find the total number of squares. In division, we know the total number of squares and one of the sides, and we're trying to find the missing side length. So that's 3 ways you can puzzle out divisions: by sharing fairly, by counting groups, or by thinking of them as being the missing number in a multiplication. Right, let's look at how that translates into some real world problems that children come across. Here's your first one. 480 people are in a queue for a ride. The ride takes people in cars of 4 people. How many cars are needed for everyone in the queue? What's the answer to that question and how did you solve it? Well, this is definitely a counting groups question. The question is asking you to find out how many 4s there are in 480. And you may do it by counting groups. You may say that, well, there's 100 4s in 400 and then we need another 20 4s. But you may also have done it by halving 480 and halving it again to divide by 4 by sharing it into 4 equal groups. Now that's absolutely justified if you think about what division is. It is counting groups and it is sharing fairly. But you may have just blown the mind of a child who's not fluent on it being both those things. If they're trying to count groups of 4 and you've halved 480 and halved it again without thinking how confusing that is for a child, you can do a lot of damage to their learning. So you just need to slow down, listen to them, possibly show them both methods and build their confidence that it can be either. You can count groups of 4, you can share fairly into 4 equal groups, and you might do that by halving and halving again. It does all connect up, but it doesn't if you don't slow down. Here's another question. 8 children share 24 sweets fairly. How many sweets does each child get? What's your answer and how did you do it? Did you split 24 into 8 equal parts and find out how many sweets there are in each part? Or did you count how many 8s there are in 24? If you counted how many 8s there are in 24, again, you could have just really confused a child because that's not what the question says. It's a sharing fairly question. Counting groups will work because both strategies work for division. But you need to make sure that the child you're working with understands that, especially if you suddenly shift to counting groups, because this isn't a counting groups question naturally. It's very lovely to set up your 8 children and to dole out the sweets. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And now we can see it. Each child gets 3 sweets, both because you've shared the sweets fairly between them and because you've counted groups of 8. There are 3 groups of 8 there. When you organise things in rectangles, it all makes sense together. Final quick point in this video. This is the calculation we just did, 24 divided by 8. It's worth asking the child you're working with, is it okay to swap the order? Will the answers stay the same? Well, of course it won't. 8 sweets divided by 24 people. Well, there's not even going to be 1 sweet each. The answer's going to be less than 1. And it's worth at this stage just reviewing which operations was it okay to swap the order for and which wasn't it, and why. It's fine to swap the order in addition because you're just putting piles of objects together and it doesn't matter what order you count them in. It's fine to swap the order in multiplication because if you organise the objects as a rectangle and turn your head sideways, you see the other multiplication and the total number of objects stays the same. But it doesn't work to swap the order in subtraction or division. It really helps if children are very precisely aware of that. I have a worksheet in production on the foundations of division, which helps people get going with very simple divisions organised as rectangles of objects and understand how to see them in that way. And that will be available soon for free download from the sites that are referenced in the description of my Rebecca the Maths Lady YouTube channel. So your takeaways from this video are that division is both sharing fairly and counting groups and finding the missing number in a multiplication. And all those ideas make sense together if you organise objects as a rectangle, which we call an array. Array is just organising objects as rectangles, and we do that because it helps everyone who's trying to do a multiplication or division understand what each other is doing when they might be using very different methods. And it's really important that you slow down when you're teaching division because you may be using a method that's not what your child is using and you can really confuse them. You need to be comfortable and confident that division is sharing fairly, counting groups and missing number in a multiplication. And you need to help your child to understand that and move between the different methods. If this video seems a little familiar, it's very similar to the Foundations of Subtraction video, where we helped children make sense of why subtraction is both counting on and taking away. And it's also the missing number in an addition. And we used the part-whole model there to help people communicate with each other. For division, the equivalent model is array. Here's a link to the video on the Foundations of Subtraction if you're interested in that just now. Well done if you've made it through this video. This is an idea lots of teachers don't understand and lots of people struggle to understand. I hope I've done it justice in explaining it clearly, but if you need to watch this video 2 or 3 times to be really confident with this idea, then it's worth doing because it makes such a difference to your capacity to teach maths in ways that really set children up to be confident mathematicians. And in this video we also talked about the fact that addition and multiplication are commutative, you can swap the order and why that is, and subtraction and division aren't. If you've any questions on this video, please post them in the comments to the video and I will do my best to respond. I'm really honoured that you're taking this journey with me. I love working with people who are passionate about teaching maths well. It's the most wonderful thing to do. Of course, it's always been best to work live, face-to-face with people, and I miss that. But I hope this is of some use to you. Okay, you've done it. This is the hardest video. It all gets easier from here, I promise. The next video is on short division, and I really hope you'll join me for that. Bye for now.